Hi, everybody. Welcome to the Trends for the Trenches podcast, co-produced by BioTeam and BioIT World. I'm your host, Ari Berman, CEO of BioTeam. I'm so excited to have David Hewlett on the show today to help me kick off the new series of Trends from the Trenches after I took it over from Stan Gloss last month. David's a well-known actor, tech nerd, lifelong learning advocate, and guy who expertly plays a genius on TV. He's acted in many TV shows and movies, including A Dog's Breakfast, Rise of the Planet of the Apes, The Shape of Water, See, Guillermo del Toro's Cabinet of Curiosities, and is probably best known for his role as Dr. Rodney McKay on Stargate SG-1, Stargate Atlantis, and Stargate Universe. Inspired by his childhood fear and fascination with Doctor Who, he wanted to become a genius Time Lord. Reality led him to acting. David created techbandits.org, a curiosity-driven science, technology, engineering, arts, and math club for kids of all ages that promotes lifelong learning via YouTube and Twitch, as well as in-person events at local schools and community centers. His enthusiasm for assistive technology led him to partner with gamer and influencer Lance Carr and Google on GameFace, an AI-powered head-tracking mouse released at Google I/O 2023. David also worked with the University of Toronto on his educational escape room design learning initiative. Beyond his creative endeavors, David actively speaks at conferences and podcasts worldwide. His goal is to inspire the next generation of brilliant minds to be brave, be kind, and be curious. Today, David and I will talk about his journey through learning in Hollywood, how science and technology have influenced his life and career choices, and geek out a little on health and life sciences related technology topics. It is my great pleasure to welcome my very good friend, David, to the podcast. Hey, David.
Wow. That was a fantastic lead in there. I feel like I'm never going to live up to that. I think we should just cut it off right there. That's fantastic.
Well, that's how I see it, so it works out.
This is the thing I love about, I think Stargate in particular, is that it allows me, not only I get to play geniuses on television, but I get to talk to them now as well. Like I get to talk to people who are at the leading edge of this stuff. And this is a perfect example. It's like we just met on, I think it was Twitter at the time.
On Twitter.
And
when it was Twitter.
Yeah, Twitter when it was Twitter, and we've just been friends ever since because we're both giant nerds.
Giant nerds, and we geek out for hours and lose time, and it's great.
Yeah, exactly.
That's really fun. Well, I know I just sort of introduced all the things, but let's start out about talking how you ended up in so many scientist roles, both very well-intentioned and some shockingly evil ones, like in C. Dude, I didn't know you could be that evil. That was awesome.
That was some pretty evil stuff, wasn't it? Yeah,
that was evil.
The makeup helps. I think the makeup, the fact that you've got, like 2.5 hours of people putting things on your face to make you look that evil is also pretty great. It's funny, isn't it? The scientist thing was, I think I've always, like you so beautifully put, Doctor Who was my inspiration. And thanks to the way that it was done up here in Canada, in order to have Doctor Who on the PBS channel that we had up here, which is our TVO, TV Ontario, they had to make up for a chunk of time at the end of it because of the British are real half hours, whereas we have commercials and things. And also, they needed an educational mandate. So they would bring in these scientists and science fiction speakers. There was Dater, Dr. Dater, and the Undoctor was this wonderful Judith, who was the science fiction writer. And they would talk about the potential, just things to think about that were brought up in the show. And I loved that as much, if not as much, certainly as much as the show. And so the science and the science fiction became sort of bound together for me. So I just always loved those scientists, the way people could answer these questions, these massive questions by just, sitting down and thinking hard about it and bringing in other brains. And so I think that's where the love of that comes from. And when you love doing something, the nice side effect of that is that people, like you doing it and hire you to do it more. So the science stuff has really been a nice niche, I must say.
Yeah, it really is. We've talked before about the rather extensive and rapid dialogue you had to learn for Stargate.
Yeah. For some reason, I got a reputation for that. There's a great story I have about RDA. So this is MacGyver. So I'm sitting on a plane beside MacGyver, and I'm going in to do our first episode of Atlantis. I'd done SG-1 before, the original show, and I'd met him there. But so I sort of knew him, but he looked like he was busy. I didn't want to talk to him, and so I bring out this giant script for the double episode pilot, and I start going through it. I'm highlighting my lines, and I'm jotting little notes down and stuff. And he sort of looks over, And then he reaches into his bag and pulls out like one little fact sheet. And he puts it down, and it's his lines. And he crosses the first one out, circles the second one, crosses out the second one, the third one, turns to me and says, if you get them wrong, they stop giving them to you. and like an idiot, I didn't take his advice. I got them right, so they kept giving more and more. And they got to the point where the writers would joke about the fact that they just kind of wanted to see how much I could say. So I was like, "Oh, great! I'm like a little mouse in your Stargate experiments until David's head explodes." But a wonderful show to work on, and like I say, what I think one of the great pleasures I got was people coming up to me after and saying like, "Oh, because of your crazy Rodney McKay guy, I'm now doing physics, or I'm in biotech, and I would, of course, go like, oh, great, tell me about it. And that's sort of how I got onto this whole, I managed to sort of turn it into a learning adventure, lifelong learning adventure for myself, in the process.
Yeah, that's pretty awesome. I told you that, your role in Stargate and other things like that sort of inspired me to bring tech and science together more.
Great.
Because I watched that show. I'm like, we can do that, I think. Yeah, we can do that,
They were very smart writers as well. Like the writers were definitely nerds, and they knew what was going on, and they kept track of that stuff. And, they definitely, I feel like they were almost frustrated scientists, I think,
Right. I mean, I think one of the things about it was that, so a lot of sci-fi has a hard time balancing the human and the technology and all of that stuff together. Stargate did it brilliantly. Like there was just a lot of human, a lot of character development, a lot of interactions, and also a lot of non-human, and and a lot of like really believable, compelling, both ancient history and far-flung future stuff all thrown in together,
Yeah, it's fun because there was sort of pseudoscience stuff, but there was also the real science, and they definitely had a lot of fun, and I had just a ton of fun doing it as well. So sci-fi is my world. I mean, I love, ever since say Doctor Who, Star Wars, all that stuff. That was all. I mean, Star Wars is more fantasy. I tend to prefer the Star Trek type of stuff myself because I like it's the science that really gets me excited. So.
When they have actual science advisors on the show,
right, which they then ignore. But that's not no. Actually, no. Star Trek doesn't. But I know that one of the big issues you get with film and TV is that it's all very good and well to we want it to be real, like really. How much? Okay, it doesn't have to be that real. Let's there's a lot of that going on. A bit like the science world, I suppose.
Yeah, absolutely. I mean, most scientific hypotheses, start completely as. What can I make up today? Can I answer that question that no one's ever thought to ask? And people think scientists are crazy because it's essentially 99% abject failure. So,
well, that's it, though, isn't it? It's that classic. Was it the Ford or was it Edison who said he had 10,000 failures that brought him to the light bulb or whatever it was?
That was Edison.
I think that's fan. I mean, like that's the beauty of it. I mean, I remember saying to the Tech Bandits kids at one point, like, and when something went right, and I was like, damn it worked. We didn't learn anything. You know what I mean? So
that's a great segue, actually. So, tell me a little bit about Tech Bandits. I've always loved that, and watched you a bit on it before we connected up, and then after also.
It's a weird kind of, like myself, a little bit. It's unfocused and changes weekly. But during the pandemic specifically, before the pandemic, I was doing some live stuff with the local school, and I would bring old computers in, and we'd pull them apart, old printers. They love pulling apart old printers, and then we started putting them together into different things, and I just used it as a great excuse to just not teach anyone anything, because I'm not a teacher. I'm almost like more like a science marketing. I like to think of myself in that they've got the collective knowledge of the human race available to them. All we have to do is inspire them to look. And so that I felt like that was my job, that I was noticing that the kids come in and there's a wonderful sort of like when I would wheel in this giant orange cart of technology, whether it was 3D printers or I brought in some biotech stuff. We had spiders one time that with laser vibrometers and, and I would wheel them in. And while I waited to go up, because I was coming in at the same time every day, this class of like kindergarten kids would come out of their pool time. And they would just beeline straight to this thing, and they'd be like, "What's that? And what does this do? And what's this?" And I'm like, "Oh, it's fantastic! It's this and that." And we talked about all sorts of stuff, and then you go take the stuff up to the class, and by grade 4, they're like, "What are you trying to teach us?" Like, what? You know what I mean? Like, it's, you know what I mean? Like, it's like they already think of learning as a bad word. And that was really frustrating to me. So one of the things I tried to get across very quickly was that I'm not teaching you anything. Like, this is, you know, this is a computer, other than stabbing the screen, which is the first thing one of the kids did. You know, I was like, take it apart. You're not allowed to cut anything. You have to use there's always another screw. So, and they would just take stuff apart. And once they got to the sense that I wasn't trying to trick them into learning something, I could trick them into learning stuff. But then the pandemic hit. We tried it online. We tried like a Zoom thing, and it was a disaster. Like, it was just because you could hear them playing video games in the background. Their screens would disappear, and I was like, this is awful. So my son said, "Well, we're not on Zoom. We use Discord." So I started using Discord because that was the gaming platform. I stopped trying to get their attention because I knew that you can't compete with the World Wide Web and every video game known to man. So I just let them play. And so for like an hour or so, we would sit around and I would talk about stuff that I found interesting. And you'd see it. They'd be like, you'd hear the clicking of video games, and then it would stop. And they'd go, whoa, wait, what was that? What's that part? What's that? And then you go, dinosaur fan. Okay, great. So that's sort of how we progressed. And then once the pandemic was over, I tried to sort of keep it going. It dwindled to the number of people who were involved. And then I suddenly went, wait a second, they shouldn't be online talking to me. Get them out of here. They don't want to be online. So again, went back to trying to make more real world stuff, which is where the escape puzzle stuff came into play. And that's been amazing. U of T just got a grant to study the effects of using escape puzzle learning as a way of learning, as a learning tool for biology, for the biology department up there. And that's because that is all because of a Tech Bandits we did, where I invited a guy who made escape rooms in, and we talked about stuff. And I suddenly went, wait a second, this should be the kids loved it. I loved it. I was like, why isn't this my final exam instead of a piece of paper? So I'm babbling, but that's sort of the way it's worked is I'm always a bit like the acting. It's just reacting, right? It's just like, what do they got? Just the ability to be able to listen to what they're and see what they're doing and then respond to that, I think it's just been amazing. It's been so much fun.
That's really cool. There's a important part in, sparking and maintaining curiosity, because learning can be fun. We've managed to standardize it into being horrible, right? Yeah. But learning it's fun, but I think the thing that people seem to forget is that it's uncomfortable. Learning is uncomfortable. It's not, if you're not learning anything if you're just sitting there and it's washing over you. It's when you have to stop and go, what? I don't get that. And it's the finishing of that learning process that is the part that's the learning. And I worry that we're getting rid of that we're trying to make it as easy as possible. And I think we're losing part of the learning in the process. Well, there's a great book I think I have over here somewhere called The Scientist in the Crib. And it's sort of about how play is science. Yeah. It's kids teaching themselves about the world. It's why they like to stab a screen. Yeah. What happens? I've never been able to do that. Ooh. Yeah, no one's let me do that before. I don't have to do that again. And I never let them do it again. Yeah, right, exactly. Well, because we discovered the glass goes everywhere. It's very hard to find where the glass is, and Yeah, exactly. So I think we can go a lot further. I think people who choose to go into science-related fields are people who enjoy self-learning. Mm-hmm. Because while there is a lot of school learning, the majority, especially in life sciences, laboratory science, and other applied sciences, getting a PhD is about like doing stuff. Like you sit down and you have to learn how to do a whole thing that no one's ever done before. And then you have to write it down so someone else can do it. Right. Exactly. Yeah. Right. And the whole point of people trying to disprove other people's stuff or prove it or, recreate it is just the whole scientific process is wonderful that way. The issue you have with biology, I've discovered, and the reason why we focused on that with the escape puzzle stuff, the reason why I wanted to focus on that was because biology requires a huge amount of
background. You need to know so many words and so many concepts before you can get into the actual like creating of this stuff. And so I thought, how do we make that more fun? How do we, if you're trying to solve puzzles is very similar to looking things up and trying to figure out how they work. Is there a way that stuff could be sort of facilitated through this process instead of just sitting down and looking at a book? Because one of my biggest frustrations with biology was, when I was in school, you got a terrible photocopy of a cell that you're supposed to label the parts on. You could barely make out what they are. And it's just an illustration. I was very frustrated to see my son doing the same thing in his biology class, 1,000 years later. So, I was like, what do we got out there? We've got 4K video of this stuff happening. Why are we pointing at static drawn images in a textbook? It seems crazy to me.
Because it's affordable.
Yeah.
And it's always worked. Why not keep doing it?
Yeah, exactly.
Right? Yeah.
Well, and the other problem with education that we find is that a lot of it becomes focused by where your kid is at in the process. So you've got problems in grade 4. You do your best to sort out grade 4, but then you're on to grade 5. So nothing gets fixed. You just get through that. It's very rare that people go back and look at the problems that their kids have had. Yeah. They're constantly looking, ahead. So
yeah, standards-based learning is like that, right? It's about checking boxes and getting funding versus actually fixing memory in the brain.
Well, and science is messy. Science doesn't click. Science isn't about little boxes. I mean, that's one of the things I love about it is that it demands, we're trying to put order to the wonderful chaos that is the planet around the world around us. And I think that this is why I find what you do so fascinating, because you are trying to quantify some of this stuff. You are trying to take these massive amounts of data and that scientists can produce, but we've got scientists sitting there watching things happen and documenting things. And I'm like, whoa, there's like AI that can, there's machine learning models and such that we can use that can help process all this amount of data, and we can speed things up. And yeah, I mean, I love the idea of like speeding up science. I think is it's just a wonderful mission to have.
Yeah, it keeps us going for sure. I mean, not to bring up a potential bad word here, but COVID, the world watched science unfold in real time, and the understanding of science was obviously not well penetrated into the world because there was all this. Well, make up your mind. What is it?
Right.
Because they'd say, unfortunately, definitively, oh, it's this, and then a week later, it's this. And they're like, well, which is it? It was like, well, we learned something. It's this. But that's not how they communicated it. So everyone was like, they can't make up their mind. They don't know what they're doing. And it's, but that was science unfolding in real time.
And why science communication is so important. I mean, is that, you know what I mean? I think that's the biggest thing. I think scientists tend to live in they get their little bubbles like we all do. And there's a tendency, whenever I talk to scientists, the first thing they always say is like, oh, what I do is boring. I'm like, no, what I do is boring. I sit around on set waiting with a cup of coffee, waiting to say my lines that I already know are, what they are. There's a tendency not to worry about how to present this to the world. And I think it's in a way it's almost as important as the science itself.
I think it might be more important in some ways, right? That science is really important, and you and I have talked about this a lot. Right? That being able to effectively communicate science to a broad audience reduces the amount of ignorance. And so much of science communication is just done wrong by not scientists, right? And I think you, through our random chats, I think we identified that you actually enjoy science communication.
I love it. Absolutely love it.
Actors essentially are communicators, right? Expert communicators. And so, you and I talked about that, and that led to you doing a keynote at BioIT World.
Yeah. How wild is that? I had a few friends' eyebrows raised on that one. I was like, because the funny thing, which I haven't mentioned, is I'm a high school dropout. I hated school in every possible way. Absolutely hated it. I would read the books and then not do the essays. But I've always loved learning. So it's just kind of there's a certain irony about being at a BioIT conference talking. But I think, having spoken to you, I mean, a huge part of obviously is talking to you and seeing how you work and what your company was doing and stuff, and seeing the sort of the pain points that you have, which is about, I think you see a lot of regulation issue stuff. You see a lot of people pushing back on something. Like the first question I had on the radio show I did an interview for a radio show while BioIT was going on. And they're like, okay, so, should we be concerned that you're going to grow something horrible in the lab type thing? There's always, we go straight to Hollywood and these ridiculous stories of it. Whereas if you can take control of the story, and I think the story with scientists tends to be about the technology. And I think what they're missing is that we need to know the people who are making this stuff, because, you trust a company because of what they do, because of their actions and what they do. If you don't know the story behind them, if you don't know the genesis of this, you had an uncle who had cancer. So I was very interested in cancer research. I did, I think understanding the people and the story behind these inventions, will turn CRISPR into the potential, world-changing technology that it is, as opposed to this ridiculous backlash from people who don't understand what's going on. And I think Hollywood's got a huge responsibility with that. We tend to go for the good story, and the good story is not a lab experiment gone well.
Although you guys, you all did that quite a lot on Stargate, which I think was one of the cool things, is that occasionally things went wrong. And I know you love people bringing this up, like, destroying a solar system, but
partial,
right? Exactly.
Yeah, not the whole.
That was something gone horribly wrong, but but often it was about things going right.
Right. And it's also what is the human response to this stuff too? I think that's what I loved about Stargate it was like it's the here and now at the time, now 20 years ago, but what with our own current understanding of the world and science do we bring to this? And we make mistakes. And I think that, one of the beautiful parts of science fiction is the speculative aspect of it. There's a wonderful YouTuber called Isaac Arthur, who does this wonderful he's a physicist by training, I guess, but he's gone off and started just doing speculative science fiction. Basically, it's not about people. It's all about the technologies and like, how do we build these ships? How do we maintain ourselves on these on longer voyages and such? So it's that speculative side of the stuff that is really fascinating to me. And also, again, and we're part of it. Like, I think we keep sort of separating ourselves from the technology and the stuff that we're building. We are a part of this. When we go to another planet, we're a part of the planet. It's not humankind going to another planet. It's a green tendril from Earth reaching out. This is, we can't separate ourselves from the environment and the planet we live on. So
yeah, for sure. And I think one of the things that overwhelms people is the breadth of information that's out there.
Yeah.
Are you enjoying the conversation? We'd love to hear from you. Please subscribe to the podcast and give us a rating. It helps other people find and join the conversation. If you've got speaker or topic ideas, we'd love to hear those too. You can send them in a podcast review.
We've talked before, these lovely devices. You now have the entire world's knowledge in the palm of your hand, and a lot of not knowledge in the palm of your hand.
Yeah.
And so it's hard to sort through, that's where science communication comes in. It's too complex for most people to follow.
It's difficult because, unfortunately, to make stuff up and put out garbage takes no thought and can be done at an incredible pace, as we can see by many of the country or state-based misinformation things. But the real stuff takes time. And I think unfortunately, the way social media has gone, it's reduced a lot of our attention spans. And I think we want quantum mechanics explained in a 30-second video. It's just not going to happen.
Nope.
But the hope is that you can at least get someone excited enough about it with that 30 seconds that they will dig deeper. But unfortunately, a lot of people, it's funny, I stopped getting a lot of science stories from social media, and I started just going to newsletters because I felt that I'm already a little scattered. So picking things up, a little bit of this, a little bit of that, a little bit of that, and not knowing anything. Whereas if I could just get a newsletter, interesting story, I could dig in and I could cover that. I would, with my email of awesomeness every week, just cover a few topics that I think are interesting, whether they're particularly current or not. It almost doesn't matter. So.
Yeah, and those are really good. I mean, they're approachable. It brings up
Certainly
cool stuff.
approachable. I don't know. We'll see
Yeah,
how
no, they
accurate
are.
they
I mean,
are.
I read the one this week, and you brought up this, neurosensor sheet, which was really
Oh
interesting.
yeah,
And
yeah.
yeah,
I mean, this stuff is this is what I love. I mean, I love the bleeding edge of technology. I love this stuff. But just basically, they've come up with a system that can grow with an organism. So while the brain of an axolotl is of a custard consistency, they can layer in this sort of this intelligent, not an intelligent mesh, but a mesh that allows them to interact with this brain matter that then folds with it and becomes the brain. And they can track this whole process. It's like going from a static image, here's it at 1 week, at 2 weeks, at 3 weeks. Now you're basically watching a 4K video of this thing forming, which of course is going to inform us about how brains develop and stuff. And this wonderful. I've always been fascinated. I think probably since Neuromancer, the wonderful William Gibson book, this idea of the brain computer interface stuff. I'm fascinated by that because I feel like if we can hack all of these things, these headphones and screens and glasses and everything, all it is an awkward way of trying to sort of trick our brain. I can't wait to get into that brain and go like, okay, you want to see a movie? Let's show you the dream I had last night. Like hacking the actual wetware is very interesting to me.
And that's going to take some time. I mean, there's a whole area of neuroscience for brain-machine interfaces that they've been working on for a long time. One of the big two of the big areas that they've made the most progress are blind people being able to see using, transistor-based CCD materials that are connected directly into the occipital lobe, and can do that. And then the other one is for paraplegics, where they're using technology to sort of bridge lack of sensory input and being able to control your muscles straight into your spinal cord.
Yeah, it's amazing
stuff.
It's the assistive stuff is something I'm fascinated too by as well. I think it's part of the brain computer interface stuff that I love so much. So I have a weird sort of fascination with accessibility. It's one of the reasons why I ended up sort of partnering up with Lance Carr, because Lance has a form of muscular dystrophy, and you should have him on one day because he's
absolutely that'd be great
talking about the accessibility side of stuff. But he was interested in what sort of like home DIY stuff he could be playing with. And so we sort of bonded on that, and then discovered we're like the same age with the same interest in science fiction and stuff, although he's a little too Star Wars for me. And we started doing a podcast about really disability rights and accessibility, and accessible tech as well. I'm more the tech, he's more the rights. But honestly, right now, there's just so much going on to talk about from that aspect. So.
Yeah, that's awesome. All right. In our last few minutes, I want to ask you, what would you like to see in the future in life sciences and healthcare? Like, what do you think technology can really help with?
Well, you got me dreaming way back when one of the first conversations we had, where you talked about trying to standardize the data that's coming out. And when I go and visit these university profs and go to the labs and talk to these various different companies doing this wonderful experiences I've been having talking to people for this I'm with Genius, the chats that I do, was that it's a mess. No one's doing things the same way. How do we organize all this stuff? So I don't know what it is. I love collecting, collector cards and stuff like that. The organizing is part of the stuff that I love the most. So the idea that we could somehow start pulling down these separate pillars of knowledge that we have about these different special areas of expertise, and then sort of have that open up to where you suddenly go, wait a second, oh, you've got that? Well, we've got this. Like that blew my mind, because I thought, so I think one of the biggest things for me is, how do we process this massive amount of data, and not just in one little area? How do we then, because once we start, once we've sucked up that and figured out how to work with that, and allowing it to talk to other databases, just seems absolutely extraordinary to me. That's certainly one of the areas that I'm most excited about. And then, as we talked about with the recent email of awesomeness, there's this lab, a company called Cortical Labs that's now put out this, they call it the CL1, and it's like something like 800,000 human neurons on a chip. And we can use it to read and write and figure out how our brains work. I am, that stuff is just extraordinary. But again, you can't do any of that unless you've got the data. And so it just comes down to data for me. I took a Google Analytics course because this high school dropout took a Google Analytics course for fun because I realized data's king. Like that's what we got to figure out what to do with this stuff, and a good reason to protect it as well. I want to make sure that stuff stays around because even data, I talk to scientists now who are working in areas that are going back and going like, whoa, there's all this data we've got from before the computer stuff. Could we use that we can, So it's new technology allowing us to process old data, You sort of think about it like, oh, well, that's out of date. But no, it's fantastic for looking back at stuff. So,
Yeah, especially for big longitudinal studies that can last for hundreds of years, where the data before 30 years ago are encoded into scanned PDFs from papers they were published in. How do you get all that? That's one thing that AI can help with, finally. Yeah. It's either that or a whole lot of graduate students, typing things into databases.
Well, that's it. That was the wonderful, like, look, while I was taking the Google Analytics course, it changed. Like I was using Perplexity and going back and forth with some of the stuff to as a sort of a search engine for how to write the right commands for Python or whatever to do the homework. And then suddenly up popped another module called AI and analytics and basically started telling me all the things that I was doing was what we're going to be doing. And I was like, whoa, wow, this is like, I'm right on that, I'm riding that wave right now. It's the tools that are available I think are just extraordinary. And I worry very much about again, the story behind this stuff, because if we keep thinking of, as you put in your talks, if we think Terminator and Skynet, how are we going to convince anyone to use these tools?
Yeah. And, AI made a big break onto the public stage, into the public consciousness with, OpenAI's ChatGPT coming out, and everyone was like, "Oh, that's AI." It's like, kinda. It's part of it. It's a cool tool. There's a lot of cool tools.
We've been using it for years. I mean, Google's been using it in the background for stuff, autocorrect, for God's sake. I mean,
autocorrect is AI, voice recognition is AI, you talk to Siri or, Google or whatever. That's all AI, or
noise cancellation. I mean, all that stuff. Yeah.
Which by the way was just a simple regression algorithm before, and now it can adapt. And the adaptive part is the AI.
Right. Of course. Yeah.
And, some people will say machine learning basically is just nonlinear regression. It's just really a complicated version of it. It's fascinating. And the data thing, you're right. I mean, that's a big tear that we've been on forever. And, because there's power in that data if you can pull it together. And with so many different formats and people, the description of the data, the metadata is not being, consistent. You just can't do it. And, I think I've described this before, but data is king, as you said. But as data, it's just data.
Yeah.
To gather knowledge from it, you have to interpret it. Right? Data doesn't turn into knowledge without interpretation. And if it's all super siloed, we lose power in that.
It just gathers dust rather than gathering data.
Yeah, it just, right. It gathers, cosmic rays and, loses bits and degrades over time. And
this is there's every so often I have these little panics about the fact that, everything we do is digital. Like what happened? I mean, is there going to be, at some point, are we going to be a civilization that if we lose that, there's no trace off? Like there's no art, there's no music, there's no, there's no science, because it's all digital. But that said, the advantage of the digital side of stuff is just, I feel so lucky because I've grown up as you to some extent, and watched the world go from a very analog world to a very computerized world, and then a networked world. And now, with the next, I really feel like AI, I don't want to be too sort of Pollyanna about it. I understand there are issues, but I think that a lot of these issues can be combated by just people understanding it better. You know, I love my mom. My mom is like, I don't, she'll kill me for saying this, but she's like 80 or something. But I think this is where I got my lifelong learning stuff. She went back to school when she was 30 to do history. Well, the other week she goes, "Oh, I can't come to coffee. I'm doing an AI course." And she's listening to the University of Toronto, the guy who literally just won a Nobel Prize, has a talk, and she's there. She goes, "Oh, I don't understand it, but the fact that she's still trying to understand this stuff is, I think, I don't understand why everyone isn't always I don't feel like there's enough hours in the day. There's too much to learn."
Lead with curiosity, not judgment.
That's it. Yeah.
Right.
You know, although I am good at judgment too, I got to say. That's the acting.
Yeah. I mean, there's that petty nature to humans.
Yeah, of course.
I got it too.
Yeah. So. I embrace it.
Just do it. David, man, this has been great. I always love talking to you. I'm sure we could go on for hours, as we usually do, but thank you so much for doing this. I really appreciate you being the kickoff of the new series here.
I am so flattered, and I am so excited to see what you do with this, because I love what you're up to, and like myself, I love how many things you can get into doing. Just even, I mean, it's amazing that one company can be involved in so many different aspects of this stuff, and I can't wait. I really enjoy. I mean, I've enjoyed what Stan was doing before, but I'm really looking forward to seeing what happens now.
Awesome. Well, David, as always, thank you so much. I'm sure we'll catch up sometime soon.
A pleasure indeed. We shall indeed.
Take care. I won't hold you up from your filming any longer before they.
Oh yes, that's right. I've got to be whisked away now. So.
Awesome. Thanks so much. I really appreciate it.
Thank you so much, dude. Thanks, everyone.